All right, I think that this is recording. We shall see. All right, so just a little bit of a rundown. This new unit, in particular lesson 2, is going to be on circular motion and periodic functions. And so this first one is going to be talking about really just like these two things, angular velocity and linear velocity. Angular velocity is right here. It's the angle of rotation about the center of a circle in a unit of time. So the sense that it's a unit of time, well, obviously, like we're rotating. For example, a wheel is rotating in a circular motion because it is a circle. But the way we would measure velocity, right? Velocity usually is your rate of change, right? How fast am I going, or how fast is something rotating? So in this case, the most common way to measure angular velocity is rotations per minute. Now, the other type of velocity we'll be talking about is linear velocity, and that is the distance traveled by a point on a circle. So imagine you've got, I don't know if I have a picture of a circle here, but I don't. But anyways, imagine, oh, we got the bike here. Imagine we've got the wheel on the bike, or I guess you could say on the crank or the pedal of this gear right here. So imagine I've got this as my circle. If I were to fixate on a point, let's say it's like right here. As this circle rotates, that point is moving its location, but wheels are moving forward, and so this point is thus moving forward as well. And so that is usually the way we would measure linear velocity. This word linear often refers to left to right or right to left. So pretty much distance, going forwards, going backwards. So a negative velocity would be like, velocity going from right to left, going backwards would be a negative velocity. A positive velocity means we're going from left to right. Now, with this in particular, if we go over what the bicycle gear ratio, so this is kind of what we did in class. This pedal is connected to this main sprocket, or I guess you could say this main gear. And as this rotates, right, that's propelled by the pedal. So depending on how fast we're pedaling, it's going to determine how fast this circle here is rotating per minute. And this is linked by a chain to this rear sprocket, which is this smaller circle in the back. Now, the relationship between the two of them is that the larger one has 42 teeth and the smaller one has 14 teeth. And so the chain, while the chain is moving at the same speed, right, the chain is still rotating about at the same rate. However, the number of teeth determines how fast this wheel will do one full revolution versus how fast the pedal sprocket will do one full revolution. So, for example, just basically, one full revolution for this pedal sprocket is not going to be the same amount of time as one full revolution for this rear sprocket. But since they tell us 42 teeth and 14 teeth, they're asking us, what is that relationship, right? One revolution of the pedal sprocket will be how many revolutions of the rear sprocket? Well, if it takes 42 teeth to do one revolution for the pedal sprocket, and it takes 14 teeth to do one revolution for the rear sprocket, if you did 42 divided by 14, you get 3. And that is what I did right here. So 42 over 14 gives me 3, which means that the pedal sprocket has 3 times the circumference of the rear sprocket, or I guess you could say it rotates 3 times, or one rotation of the pedal gives 3 rotations of the rear sprocket, or it takes a third the amount of time. One rotation of the rear sprocket is a third the amount of time that it takes for the pedal sprocket. So this is all about ratios and the relationship between the two. But basically, the pedal sprocket is 3 times as big as the rear sprocket. Therefore, one revolution of the pedal sprocket gives me 3 revolutions of the rear sprocket. And that's what we see right here with this angular velocity. So in part B, they say, suppose that the rider is pedaling at an angular velocity of 80 revolutions per minute. So the pedal, right, they're pedaling, so that means the pedal sprocket is going 80 rotations per minute. So if this is rotating 80 times per minute, how many times does the rear sprocket rotate or revolve in that same minute? And that is by doing 3 times 80. Because if the pedal is rotating 80 times, the rear is going to rotate 3 times more than that. Now, what is the angular velocity of the rear wheel? This is more of like a mountain biking question. Basically, if the rear sprocket, it's directly related to the rear wheel. So if the sprocket rotates once in the back, so the rear, the wheel is going to rotate once as well. All right, moving on, because I don't want this thing to be too long. I don't know if I'll be able to upload it. Number 2, suppose that the wheels on the mountain bike have a radius of 33 centimeters. Now, if we know that the radius is 33 centimeters, we can use that to calculate the circumference. And we definitely need the circumference because if you think about it, if we're trying to measure linear velocity, which we will eventually here, we need to be able to know, right, the circumference of the circle is the distance around a circle. So if we know the circumference of a wheel, that'll tell us how far we go with one revolution of the wheel, if that makes sense. So they have us figure out how far does the bike travel for each complete revolution of the 14-tooth rear sprocket. So if we've got the 14-tooth rear sprocket, one full revolution of that rear sprocket, so again, we're ignoring the pedal, one full revolution of that is going to be, oh, I got these out of order, it looks like. There we go. Maybe I can't order them. There we go. Sorry about that. One revolution of the rear sprocket is going to give one revolution of the wheel. So let's figure out the circumference of the wheel, because then one revolution of the wheel will tell us how far we go. So the way we calculate the circumference is going to be pi times diameter. My radius is 33, so double that and gives me my diameter. So 66 pi is going to be my circumference. And so one revolution is going to be one circumference as my distance. And that's approximately, when I do 66 times pi, I get 207 centimeters. So one revolution of my rear sprocket gives me 207 centimeters in distance. The same thing can be calculated for one revolution of the pedal, only one revolution of the pedal sprocket gives me 3 revolutions of the rear, therefore 3 revolutions of the wheel. And so we would just multiply this same thing we calculated here, but by 3. Kind of like what we did in number 1 with the angular velocity. But now this is kind of calculating linear, right? Because we're talking about distance, not rotations. Now in part C it says, if the rider pedals at an angular velocity of 80 rotations per minute, how far will she travel in a minute? So now this is actually part C is asking us, what is the linear velocity? So when we get there, so the 80 RPMs from the pedal sprocket is equivalent to 240 RPMs of the rear sprocket, therefore 240 RPMs for the wheel. We kind of established that up here in problem 1. 240 revolutions per minute is the same thing as 80 revolutions per minute for the pedal sprocket. So right here in letter C of problem 2, we know that the wheel is going to rotate 240 times per minute. The first step is always to figure out, all right, if I'm trying to calculate linear velocity, I need to know what angular velocity is. And the angular velocity of the wheel is different than the angular velocity of the pedal, but they only tell us the pedal's angular velocity, 80 RPMs. So we have to convert it to the wheel's angular velocity, which is going to be 240 RPMs. Now we're going to do that same thing. Above, we just did 1 revolution, but now we're going to calculate it for 240 revolutions. So when we do 240 revolutions times the circumference of the wheel, aka our wheel is going to spin 240 times per minute. So how far are we going? Well, if we know the circumference of the wheel, we can calculate that distance. And so 240 times the circumference of the wheel, which is 66 pi, gives me 49,762 centimeters per minute, right? when we're talking about linear velocity, it usually refers to distance per minute or distance per hour or whatever the units you're using. And then I'm going to skip D, but that basically gives it a solution. But anyways, we're moving on. So when we get to number 3, it says, okay, in the connection between the pedal and the rear sprockets of a bicycle, the pedal sprocket is the driver and the rear sprocket is a follower. Driver in the sense of the pedal is the driver and it dictates what is our motion going to be, like where we're going, what speed are we going at. So the driver, the pedal, is what determines your speed. Makes sense. So it's the driver, and then inherently the follower is going to be the rear sprocket because it's going to follow based on the chain, right? The pedal moves the chain at a certain speed, and that rear sprocket, aka that rear wheel, is going to move based on your pedal speed. So the official terms are the driver and the follower. So what rules could we make to relate the different velocities? So the velocity, so V subscript D represents your velocity of the driver, and V subscript F represents the velocity of your follower. So let's say your driver, so your pedal sprocket has 30 teeth, and the follower sprocket has 15. So like before, in problem 1, we determined that the relationship between the two is by taking the driver's number of teeth, or I guess you could say, or reference of measurement. In this case, it's the number of teeth. So here we said, okay, well, 1 revolution of my driver, or my pedal sprocket, is 42 teeth, and divide that by the revolution or number of teeth or the measurement that we have for the other, the rear, the follower, and we get 14. 42 over 14 is 3, so that means the driver is 3 times more than the follower. Or in other words, 1 revolution of the driver is going to be 3 revolutions of the follower because the follower is smaller, so it's going to rotate more quickly, I guess you could say. So for number 3, we do 30 divided by 15 and it equals 2 right here. 30 divided by 15 equals 2. So that means 1 rotation of the driver gives 2 rotations of the follower. So that means that the velocity of the follower equals 2 times the velocity of the driver. In the textbook, I believe they say you could switch this around and you could say that the velocity of the driver equals half the velocity of the follower. That would also work. Because basically the speed of the follower is going to be moving twice as fast as the driver. But if we're just looking at the driver's velocity, how fast it's rotating, or how fast it's moving, right? They're directly related. It's going to be half the speed of the follower one. Now in part 2, they say the driver sprocket with 20 teeth and follower sprocket with 30 teeth. So this driver sprocket with 20 teeth and follower sprocket with 30 teeth. I just said that twice, my bad. The driver sprocket is now the smaller of the two, and the follower is 30. So, but you still do the driver divided by the follower. So we do 20 divided by 30 and we get 2/3, which means that 1 rotation of the driver gives 2/3 rotations of the follower. So how could you calculate the follower? Well, the velocity of the follower is going to be 2/3 times the velocity of the driver, right? Because one rotation of the driver is going to give me 2/3, right here, 2/3 rotations for my follower. Now I think this is where it gets a little bit confusing in terms of writing these equations. But I think if you were to flip it and make it the velocity of the driver equals 1/2 the velocity of the follower, that might almost make more sense. And in this case, it would be the velocity of the driver equals 3/2 times the velocity of the follower. But either way, you got to be thinking about the relationship between the driver and the follower. What's the driver? What's the follower? So when we move on when you move on to number 4, 5, and 6, really pick what's my driver and what's my follower. The crankshaft is going to be the driver, the alternator will be your follower, or the fan pulley will be your follower. But depending on the question they ask, it will require you to decide which is which. I hope that this was helpful, just to kind of give very detailed. I'm sorry that it got a little bit long, but I feel like the longer video, the longer explanation, if it gives me a deeper understanding, is definitely worthwhile. So let me know if this works, or sorry, if this helps, and we'll go from there. Now I got to figure out how to stop this thing. And I think I need to find... Oh, here we go. Got it. Bingo. All right, see you guys.